So good evening. So today's discussion is n queens problem. N queens problem is solved using the technique that is called backtracking. So using backtracking we can solve n queens problem. So what about the problem definition? The problem definition says it is basically a classic combinatorial problem which is to take the objective as we have to place n number of queens on an n into n chessboard in such a manner so that no two queens attack each other. That is, no two of them share the same row, same column or diagonal. So for an example, if we have taken n equals to 4, so basically it is a 4 queens problem. So definitely we have 4 into 4 chessboard in hand. Suppose this is a 4 cross 4 chessboard. First row, second row, third row, and first, second, third and fourth row. And definitely there are 4 columns, 1, 2, 3 and 4. 1, 2, 3, 4. 4 rows, 1, 2, 3, 4. 4 columns. You have to place 4 queens. Suppose the queens are Q1, Q2, Q3 and Q4. You have to place all 4 queens into this 4 cross 4 chessboard so that no two queens attack each other. That means they should not share the same row, same column or even same diagonal. So to avoid the row conflict, let us assume that each and every queen share one row. That is, for first queen, let us consider first row. For second queen, assume that it will be placed at second row. For third queen, it will be placed at third row, and fourth queen for fourth row. So now take the first queen. So suppose queen 1 means row 1. So at the first row, first column, suppose you place first queen. So enter first row is blocked, enter first column is blocked, and enter principal diagonal is blocked. There would be another diagonal which is called upper right to lower left. As it is not applicable here, so we are not considering it. So normally, if this is a position of a particular queen, so this diagonal and this diagonal both are blocked with respect to this particular queen. So as it is first row, first column, this diagonal is absent here. So now queen 2. So queen 2 means row 2, because I have assumed that each row is utilized by a particular queen where the queen number will be similar as the row number. So in this case, there is a safe place for queen 2. If this is the place for queen 2, enter second row is blocked, third column is blocked, this diagonal is entirely blocked. So if you go for third queen, there is no safest place for third queen. This column is blocked with respect to queen 1. This one is blocked with respect to queen 2. This one is blocked with respect to queen 2 and queen 1 both. And this one is blocked with respect to queen 2. This is the upper left to lower right diagonal. So here the first point of backtracking comes into the picture. That means you have to shift queen 2 immediate the next cell, that is cell number 4. So this is the place for queen 2 now. So if it is the place, then here, that is row 3 column 2, is the safest place for queen 3. So if you do it, the entire fourth row, you will not find any suitable position for queen 4, because this is blocked, this one is blocked, this one is blocked, this one is blocked. Okay, so if you want to represent the solution in the solution vector, then it is a vector with 4 cells present in it. Because it is a 4 queens problem and as per the first lecture of backtracking, it was told that there should be a solution vector under which you have to load the solutions of the backtracking related problem. Here we are dealing with the 4 queens problem, so the length of the solution vector will be 4. Indexing says that it is the number of the queen, index 1 for queen 1. Similarly, this index implies the row number in the chessboard. And under this particular cell, whatever entry that you want to put, it is basically the appropriate column number for that queen. So as per the solution where we have stopped for moving further, queen 1 is placed at row 1, column 1. So put the column number here. Queen 2 was earlier placed at row number 2 but column number 3. Fine. So queen 3 is of having problem in this arrangement. So we need to alter the position of the queen 2. So queen 2 is shifted from column number 3 to column number 4. So it was changed at 4. Then queen 3 got its suitable position at column number 2 under row number 3. So put the column number here. So partially generated solution vector gives us no way to place queen number 4, because if you write queen number 4 here, that is if you place queen number 4 here, that means column number 1 under row number 4, there is a conflict with queen 1. If you place queen number 4 here, that is under column number 2, so there is a conflict with queen number 3 because they are sharing the same column. If you go here, there is again a conflict diagonally. If you go here, there is again conflict diagonally, or even in column wise for queen 1 and queen 2 respectively. So the entire solution is cancelled. So we have to rethink. Rethink means, shall we shift queen 3 further in the next cell? Unfortunately, it is not possible because queen 2 put an objection. Queen 1 is also putting an objection. Can we place queen 3 here? No, again there is an objection. So forget about the movement of queen 3. So come back to queen 2. That means we are backtracking. Queen 2 don't have any option to move further. So go back to queen 1. Queen 1 has 3 pending columns. Column 2, column 3 and column 4. So you can easily shift queen 1 from column 1 to column 2. So again we are generating the solution. Okay. So the first solution is cancelled, because I told once a solution that was partially constructed is not leading to the perfect solution, so you need to discard it. So it was like the Sudoku problem I told, once a digit is not perfect, you discard and try for the next one, that means the next suitable one. That means once a particular digit is not leading to the solution, then discard it. So this solution, which is partially constructed, because still this cell is not yet filled up to this it was not accepted, so you discard it. So now queen 1 is shifted from column 1 to column 2 under the first row. So first row, second row, third, fourth, first, second, third, fourth. So queen 1 is now here. So now construct the solution vector as 1, 2, 3, 1, 2, 3, 4. So queen 1 is at row 1 but column 2. So put the column number here. This indicates queen 1, this indicates row 1 also, because I told each row for each queen. Then this cell is blocked, this entire column is blocked, this row is blocked, this diagonal is blocked, this diagonal is also blocked. So queen 2 can be placed here without any tussle. So row 2, column 4, row 2, column 4. Fine. So this is block, this one is block, this one is also block. So this is also block. So queen 3 can be placed at column number 1. So 3 is placed at column 1. Queen 3 is placed at column 1. And finally queen 4 can be placed here without any problem. There is a problem, there is a problem from both the sides. This is free. So queen 4. So queen 4, row 4, column 3. Row 4, column 3. So this is one solution. 2, 4, 1, 3. Because as per the definition of the backtracking, it was told that you have to finally build up a vector one component at a time and to test whether the vector being formed has any chance of success. The first case, we thought that the vector that we are forming had a chance of success, but it was unfortunate. So up to this limit we got that we don't have any scope to place queen 4, so we discard it. So we move on here. So this is one of the solutions. Okay, another solution you may try, that is the mirror of this solution, 2 4 1 3 mirror. Okay, so this is basically the problems of n queens. Okay, here we explain 4 queens, but it is basically the problems of the n queens. So now we will go for determining when 2 queens are of having the row conflict, when 2 queens are of having the column conflict, or even when 2 queens are of having the diagonal conflict. Because if you derive the formula, you can proceed for algorithm. Suppose you have this chessboard, and suppose we are talking about a 4 queens problem. We may deal with 8 queens problem also. Let us assume that we are dealing with 4 queens problem again. So 4 queens problem is you have a chessboard of 4 cross 4, row 1, row 2, row 3, row 4, column 1, column 2, column 3, column 4. So now assume that this is a particular cell, and suppose the chessboard is named as A 1 is to n, comma 1 is to n. Suppose n is 4. So 1 is to 4 means chessboard A, that is matrix A, have total 4 row and total 4 column, where row index starts from 1 and repeat up to 4. Column index starts from 1 and repeat up to 4. In general it is n into n. 1 is to n means row start from 1 and repeat up to n. This 1 is to n means column also start from 1 and repeat up to n. Here I have assumed that it is a 4 queens problem, so the value of n is 4. Okay. Suppose this is one position which is called as 2, 2. That means row 2, column 2. Suppose one queen is already placed here. So if a particular queen is placed here, so the entire second row is block, entire second column is block. Block for what? Block for the next queen. This diagonal is block and this diagonal is also block. So unfortunately, if the next queen is placed here, there is a conflict. If the next queen is placed here, there is another conflict. If the next queen is placed here, this is another conflict. There is no queen can be placed here, can be placed here, can be placed here, can be placed entire second row. But how do you judge it? Okay, so let us write the diagonal indexes. This is 1 1. See it? If it is 2 2, this is 1 1. So what about this one? 3 3. What about this one? 4 4. What about this one? That is upper right to lower left. This is 1 3. What about this one? This is 3 1. Okay. So if it is 2 2, 2 2 blocks 1 1, 2 2 blocks 3 3, 2 2 blocks 4 4, 2 2 blocks 1 3, 2 2 blocks 3 1. All those cells are blocked due to 2 2. So now if we take this one, you make the difference of the indexes. 1 minus 1 0, 2 minus 2 0, 3 minus 3 0, 4 minus 4 0. You take it this one and apply addition. 1 plus 3 4, 1 plus 3 4, 2 plus 2 4, 3 plus 1 4. Okay, fine. So now if we go for the positions, so if a queen is placed at row number 2 and column number 2, no other queens can be placed at row number 1, column number 1, because it is diagonally clash. Row number 3, column number 3, it is again diagonally clash, and row number 4, column number 4, it is again diagonally clash. Similarly, row number 1, column number 3 is blocked due to 2, 2. So row number 3, column number 1 is also blocked due to this queen 2, 2. That means no other queens can be placed at this cell, this cell, this cell, and even these two cells. So how to find out the relationship? So if you move on to upper left to lower right, then if you make the differences between the indexes of the queens, that means row and column difference, it is 1 minus 1 0, it is 2 minus 2 0, it is 3 minus 3 0, it is 4 minus 4 0. Similarly, if you count the upper right to lower left, if you want to find out the relationship between the indexes of the queens, that is then the summation, that is row plus column, that is 1 plus 3 4, 2 plus 2 4, 3 plus 1 4, this is same. So similarly, in the same chessboard, if you consider this is the position, so if it is the position, this row is block, this column is block, this diagonal is block. So what is the position in terms of row and column? Second row, third column. So it blocks the row, it blocks the column, it blocks the row, and it blocks the diagonal. Okay, so enter second row block, enter third column block. Then what about the diagonal position? If it is 2 3, the diagonal is 1 2. What about this position? This is 3 4. Yes. What about this one? This is 1 4. Okay. What about this one? This is 3 2 and this is 4 1. 3 2 and this is 4 1. So again the same relationship happens. 1 minus 2 minus 1, 2 minus 3 minus 1, 3 minus 4 minus 1. So the difference is same. Earlier example the difference was 0. Here the difference is minus 1, but the same. Here 2 plus 3 5, 3 plus 2 5, 4 plus 1 5, even 1 plus 4 5. So how to judge when two queens are attacking each other in terms of diagonal relationship? Assume that this center part, which I assume that this is the position of a particular queen, and you are judging whether the other queens can be positioned into the diagonal with respect to this one or not. So suppose I comma j is the column number of the queen j under row number I. That means a queen I is placed at column number j. That means queen 2 is placed at column number 3, like. So in terms of diagonal, which part are blocked? Now consider it. Suppose this is another queen and its index is KL. This index is KL. This index is KL. This index is KL. This index is KL. That means I am considering two queens. One queen is at ith row jth column. Another queen is at kth row lth column. So they are having the clash in terms of diagonal if this two relationship follows. That means this one says I minus j equals to k minus l. That means their difference is same. And the other relationship is I plus j equals to k plus l. This two. That means if these two relationship satisfies, that means either or, then I j, that means ith queen at jth column and kth queen at lth column are having conflict. Okay, again I am telling, I am considering two queens. One queen is placed at ith row jth column, another queen we want to place it at kth row lth column. This is already placed. This one we want to place in the chessboard. I have to judge whether they are of having row conflict, column conflict, or even diagonal conflict or not. To judge they are of having row conflict means I and k, if it is same, that means they are of having row conflict. J and L, if it is same, that means they are of having column conflict. For diagonal conflict, if any one of these two relationship is true, that means they are of having diagonal conflict. So in this way you can judge whether two queens are of having the conflict or not. Suppose I is 3, j is 2. That means one queen is already placed at third row, second column. So if the new queen which I want to place chooses the row 3 and column 1, there is a conflict. They cannot share the same row. Again, if the first queen is placed at, first queen means assuming that this is my current queen number. If the one queen is placed at third row, second column, and if second queen wants to be placed at, suppose, fourth row, second column, there is a column conflict. So similarly, I, J, K, L. And if they are of having the diagonal conflict, using this formula you can judge. So combining these two, that means I minus J equals to K minus L. This is the first formula. Second formula is I plus J equals to K plus L. This is second formula. Combining these two, just rearranging it. So let us write J minus L equals to I minus K. You can rearrange this one. Similarly, you can write J minus L equals to K minus I. So combining these two, you can write modulus of J minus L equals to modulus of I minus K. Okay. So if this relationship satisfies, then ith queen at jth column and kth queen at lth column have the conflict. In which conflict? Diagonal conflict. If I equals to k holds, which conflict? Row conflict. If j equals to l hold, which conflict? This is called column conflict. So in this way you can derive the formula when two queens attack each other. Again I am telling, I have the plan to implement 4 queens problem. I have a 4x4 chessboard. I have to place all 4 queens into suitable positions so that no 2 queens attack each other. The condition is they will not share the same row. The another condition is they will not share the same column. Last condition is they will not share the same diagonal. And both the diagonal you need to consider. So how to judge that they are sharing the same row, or how to judge they are sharing the same column is very easy. If a queen is placed at ith row and jth column, if another queen wants to be placed at kth row and lth column, I and k, if it is same, that means they are sharing the same row, which is not acceptable. If j and l are same, that means they are sharing the same column, which is also not acceptable. To judge whether they are sharing the same diagonal, this is the relationship. Modulus of j minus l equals to modulus of I minus k. In this relationship will tell you that they are of having diagonal conflict. So combining these three, you can easily judge whether they are of having row, column or even diagonal conflict. Your question may be, why should we consider the row conflict under this scenario? We should not consider the row conflict under this scenario because we assume that one queen for one row. So there is no chance of row conflict. Only there are two chances. One is either they are conflicting in terms of column or they are conflicting in terms of diagonal. So in the algorithm section, you will find two checking. One is for column based conflict checking and another one is for diagonal conflict checking. Okay. In the next section, we will implement the algorithm that will help us to identify the point of backtracking of a particular queen, and we will show how the solution vector is being updated. Okay.